Hi everyone, welcome back to another Calculus 12 lesson. Today we're doing 4.3, the first derivative test. And I've already sort of laid this out for you, but I think you'll find that this is, of course, as always, review of stuff that we did in the last few lessons. So, if we take a look at this, the first derivative test, there are 3 different cases. And I believe you know this from before. If we look at this, C is the critical number or the critical value. So let's take a look at the first scenario. If we have the derivative f prime of x that goes from positive to negative at the point C, so at this point here, we have a local maximum. I pretty much did show you exactly this in the last lesson. So if the slope goes up and then down, we know that that's an indication that it's going to be a maximum. And if the derivative goes from the derivative or the slope, same thing, if it goes from negative to positive at this point C, then we know we have a local minimum. So notice that here we have a negative slope and then it goes to a positive slope. So we know that it is a minimum at that point. And the third case, this is the one that I don't think we've encountered yet. If our derivative does not change sign at the point C, then there is no minimum or maximum. So notice that here it's a negative slope and here it's also a negative slope, the two values in blue. That tells us that it doesn't have a minimum or a maximum, and this kind of looks like a cubic function or some of the functions we've seen in the past. Okay, so let's get into how this would look algebraically. So in the first example, it says determine if f of x equals 6x minus 6x squared has a max or a min at its critical point. Okay, so first thing, critical point or critical value, let's first find that by taking the derivative of this thing. And as you know, I like to keep things consistent. So if I have this function and it's given as f of x, then I want to make it f prime of x. And I want to take the derivative of it. So I have 6 minus 2x when I take the power rule there and there, as we know from before. So there's the first step. Second step is let's find the critical point by setting the derivative equal to 0. So we have 6 minus 2x, and we're going to make that equal to 0, right? So the first step is always find the derivative. Second step, set it equal to 0 and solve. So when we move things around here, I'd get negative 2x equals negative 6 when I move this, slide it to the other side. So we can see by doing this that x is actually equal to 3. So we took the derivative, we set it equal to 0, we found the critical point, and then this third step is that we want to test points on either side of the critical point. So this critical point here at x equals 3, I would want to, I think I'm going to move up here to keep them all together so we can see everything. Let's say on a number line we have this point 3. I want to check, well, I don't know, maybe on this side I could do 4, 5, Maybe I want to test 4, and actually let me color code this. So maybe over here if I want to test the value of 4, and maybe on the other side 2, 1, 0. So why not try 0, because it's, as we know, it's the easiest, nicest one to work with. So basically, let me do that here, f prime of 0. I just want to take that and plug it into my equation here. So I'd have 6 minus 2 times 0. You know me, I write out every single little step so you can see what's happening, but you don't have to do that. I just want to make sure it's clear in your notes and you can clearly see what's going on. When we work with this, that's just wiped out, as we know. That's why we like to use 0. So we would get that it's equal to 6. Which is positive. So that tells me that it's increasing. Increasing. at this point. I don't know why that's underlined, but basically I know that if that was my critical point, or my critical point, I'm going to do it in green to keep it consistent, then I know at that point that my slope or my derivative would be going upwards. Now let's do the same thing with this value of 4. So f prime of 4, I want to plug it in, 6 minus 2 times 4. And so I can see when I work my way through this, f prime of 4 ends up being 6 minus 8, so it's negative 2. So my f of x at this point is decreasing. So I know that it would be going downwards this way. And so that tells me, therefore, that's my little symbol for therefore, we know that we have a maximum because of the fact that it went upwards to downwards, so it changed directions, indicating that there's a maximum and not a minimum at that point. That's it. I hope that you found that helpful. Here's your assignment, page 182, numbers 1 to 4, odd letters, and number 6.